Hi everybody, we are talking about discrete random variables, probability distribution function, and expected value, and we will be using Rguroo as our technology. Before we get into discrete random variables, I want to talk about inequality symbols and inequality wording. So on the screen you will see the four main inequality symbols. I'll add another one. This one will come into play later. But let me walk you through what each of these symbols mean. So the first symbol is less than. And the way that I remember this, and there's all sorts of ways that people remember which symbol is which, but this is the way I remember it. If the sign were an arrowhead and I were to make it an arrow, ask yourself which way does it point? This arrow points left, and I think left, left, less, left, less. So that's how I remember. Less than always points left. If there is a sign underneath the symbol, it also implies that it could be equal to as well. So this one is less than or equal to. The next one obviously is not less than because it points to the right. So this one is greater than. And then when we have the line underneath, it means greater than or equal to. And then we will eventually see this next one come into play, although not in this particular section we're covering today, but I figure I'll go ahead and introduce it. This symbol that looks like an equal sign with a line through it is not equal to. So an inequality is implies that the two numbers are not equal. So if they're not equal, the two numbers could be less than, greater than, or not equal to. And then we also have the less than or equal to symbol and the greater than or equal to symbol. So those are the symbols. All right. And remember, less than points left, which means greater than points right. So I want to talk about some wording, though, that we will see that implies inequalities. So I'm going to use the number 5, and then I'm going to say for the numbers 1 through 10. All right, so if I had the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and then I said which numbers are and then what if we said greater than 5? So we would use the greater than sign. So greater than 5. So numbers greater than 5. All right, so those numbers would be which numbers are greater than 5. So that greater means bigger. So those would be 6, 7, 8, 9, 10. So those are the numbers 6, 7, 8, 9, and 10. Notice 5 is not included. All right, so then if you had which numbers are less than 5, so numbers less than 5. Those numbers that are less than 5 would be 4, 3, 2, and 1. They do not include 5, so 1 through 4. All right, so most people are probably okay with those. If I said what numbers are greater than or equal to 5. So those numbers would be greater than would be 6 through 10, but or equal to would include 5. So we would say the numbers that are greater than or equal to 5 are 5, 6, 7, 8, 9, 10. And then if I had less than, oops, or equal to 5, it would be all the numbers that are less than 5, but also equal to 5. So it wouldn't just be 1 through 4, it would also include 5. And so I think most of these, everyone is usually familiar with this, although it is good to review it. But I want to introduce you to some wording that you may not be as familiar with, but you will definitely see as we go through these probability sections. So I want to talk about this wording here, at most 5. At most 5. So the confusing thing is that we're using the word most, and you sometimes associate the word most with more, so you would think this applies greater than, but it doesn't. At most 5 is the most it can be. It can't be any more than 5. At most 5. I'm going to go ahead and put another one that's similar. No more than 5. These mean the same thing. The number is less than or equal to 5 because it can't be bigger than 5. And so those numbers are 1, 2, 3, 4, 5. And some wording you'll see that is the opposite, at least 5. So again, you see the word least and you think, oh, least means less, so these should be less than 5, but at least 5 means it's no less than 5. So I'm going to write that out too. No less than 5. So both of these imply that it's bigger than or equal to 5. So at least or no less than means it can't be any less than 5. So it has to be 5 or more. So those are the numbers 5, 6, 7, 8, 9, and 10. Again, if we were using just the numbers 1 through 10 and we applied these statements, those are the numbers that would work in those inequalities. And so these are things to keep in mind as we move forward in these sections. Greater than, less than, greater than or equal to, less than or equal to, at most, no more than, at least, no less than. You will see all of these phrases and you will need to know what each one means. So definitely go through and study through these and make yourself familiar with them. All right, so on to discrete random variables. So if you were to roll 5 dice at one time, right? Not more than one dice, you had 5 in your hand and you shook them up and you rolled them. What would be the probability that all 5 of them would come up odd? Or what would be the probability that only 4 of them would come up odd? So this is definitely more complicated than the simple probability that we've done in the past. There'd be a little bit more to it. But that's what we're going to study in this section, is these more complicated probabilities. So in order to do that, first let's introduce you to some vocabulary. So the first word is, or phrase, is random variable. We're going to talk about random variables, and all that is it's a numerical outcome of a probability experiment. So it's a variable because it could change. You never know what's going to be the outcome. Like if you were to roll one die, just one, you have no idea if it's going to land on 1, 2, 3, 4, 5, or 6. It's random. So all the numerical outcome of a probability experiment, that's a random variable. And specifically, we call it a discrete random variable if the possible values are those that can be listed. So think about the definition of discrete that we talked about before. Those are numbers that can be listed or counted. So discrete random variables would be random variables whose possible values can be listed. Examples would be a number of heads when flipped flipping a coin 10 times. So if I flipped a coin 10 times, I could have no heads, I could have one head, I could have two heads, I could have three heads, all the way up to 10 heads. Or the number that comes up when you roll a die. So variables that the values that can be listed. All right, so other things you need to note is notation. So if you were talking about random variables, that's denoted with a capital X, but if you are referring to the values themselves for the random variable can take on, we use lowercase x for that. This, though, is important. When you see P parentheses X, that's the probability that X will occur. It's the probability that you'll get a specific random variables. Like, what's the probability that you will get 7 heads if you flip a coin 10 times? And that's how you would write it. Okay, so then we can put all of the probabilities together of all the possible outcomes into what is called a probability distribution. So probability distribution for a discrete random variable is where we list all the random variables and then we include the probability of each occurring. It's very similar to a frequency distribution that you've seen in the past, except instead of classes, we have our random variables, and instead of relative frequency, we have our probability of each. So if you'll see this example here, this table you see below, it says roll a die, a number cube with 6 sides. And there's a picture. Let X be the number that comes up. So the number that comes up could be 1, 2, 3, 4, 5, or 6. So we want to list the probabilities of each. And so the probability of rolling a 1 is 1/6. The probability of rolling a 2 is 1/6. 3 is 1/6. 4 is 1/6. 5 is 1/6. And 6 is 1/6. They actually all happen to be the same probability. Now, the probabilities won't always be the same. It just depends on what the discrete probability experiment is here. But basically that's what you do is in one row or column you list the random variable possibilities, and in the other you list their corresponding probabilities. So here is a sample space as if you rolled two dice. And if you roll 2 dice and let X be the sum of their values, build a probability distribution. So just real quick, go through and fill in the sums. So if I were to add these together, like 1 plus 1 would be 2, 1 plus 2 would be 3, 1 plus 3 would be 4. So I'm going to pause the video, you pause it too, and fill those in. Okay, I have mine filled in. You can see I have the sums written above each one, and I can see that there's 1 2, there's 2 3s, 3 4s, 4 5s, 1 2 3 4 5 6s, 1 2 3 4 5 6 7s, 1 2 3 4 5 8s, 1 2 3 4 9s, 1 2 3 10s, 1 2 11s, and 1 12. All right, so that's going to help us with this next section. The sum can be anything from 2 to 12, right? So we're going to make a probability distribution. So I've already listed the random variables. Now, if you go back up here, you can count how many of each there are. There's a total of 36 outcomes. 36. So what would be the probability of rolling a 2, a sum of 2? So there's only one way for that to happen, right? That's one way out of 36. So you would write 1 out of 36 here. So pause the video and go ahead and see if you can fill the rest of these out. Okay, so here are the answers. The probability of a 2 is 1 out of 36. A 3 would be 2 out of 36. 4, just go back up 4. There's 1, 2, 3 ways out of 36, so on and so forth. If you were to, and this would be a probability distribution, just all the probabilities as fractions, but if we wanted to convert the probabilities to decimals, if you wanted to do that, here we go. there are those. You can check those off. So you can list a probability distribution in fraction form for the probabilities or decimal form for the probabilities. All right, so if I were to flip a coin twice, let x be the number of heads, build a probability distribution function for the experiment. So sometimes it's helpful to figure out the sample space first. So what are all the different things that could happen? So if I did a coin twice, the first, let's do a tree diagram, heads or tails for the first coin. For the second coin could be heads or tails. And then if the first coin was tails, the second could be heads or tails. So I have heads and heads, heads and tails, tails and heads, tails and tails. So it looks like 4. And so I've listed them here as well. So here are your 4 outcomes. So when there's heads and heads, that's 2 heads. Heads and tails, that's 1 head. Tails and heads, that's 1 head. Tails and tails, that's 0 heads. So that's 4 outcomes. 4 outcomes. So the probability of getting 0 heads. So here are the possibilities: 0, 1, and 2. So we put this in the table. So the probability of 0 would be 1. I'm sorry. Probability of 0 would be 1 out of 4 because there's 4 outcomes. And the probability of a 1 would be heads and tails or tails and heads. So that's 2 out of 4, which is 0.5. And the probability of a 2, there's only one way that can happen out of 4, so it'd be 0.25 as well. So sometimes it's helpful to list out that sample space first so that it can help you to count all the possibilities for your random variables. You can use it here too. So there's 5,000 undergrads at college. The following frequency table describes how many of them are given. I'm sorry, let me start over. There are 5,000 undergrads at a college. The following frequency table describes how many of them are taking a given number of courses, 1 through 6. So the 478 are taking 1 course, 645 taking 2, 568 taking 3. You can read through the rest. This totals, if you add these together, that's 5,000, which means we can find the probability of each. So the probability of 1 is 478 out of 5,000. The probability of taking 2 courses is 645 out of 5,000 because you put the number of ways it can happen out of the total. So we keep doing that. You can pause the video and finish this, and then I'll go over the answers. All right, so I believe I have these in decimal form. Yep, there we go. So this is what they would be as decimals. So again, it's taking all of the frequencies at the top and dividing it by the total altogether out of 5,000. So if you think about this, though, this is the same as what would be a relative frequency. So relative frequency and probability are very closely related, and in this case, they're the same thing. You find it the same way. All right, so here are 2 rules for probability distributions that are important to note. One is that probabilities are always between 0 and 1. They can include 0 and 1, but you won't have any probabilities that are negative, so no probabilities less than 0 and no probabilities bigger than 1. All right, so no probabilities bigger than 1, no negative probabilities. While we're talking about this, real quick, scientific notation. In the calculator, it might look something like this. 5.8 times 10, I'm sorry, 5.8 in the calculator, it would look like this. 5.8 e negative 4. All right, so what that means is it it's a number that's actually smaller than 1 but bigger than 0, even though it looks like it's bigger than 1. So you could get an answer like this, which is why I'm bringing this up. So you get an answer like this and you're like, wait, 5.8 is bigger than 1. That can't be a probability. But it can. So just, this could be review. Hopefully it's review. What we do is we take our 5.8 and we take the decimal and you move it this many places in the direction of its sign. So if it's positive, move to the right. If it's negative, move to the left. So we're going to move to the left 4 spaces. 1, 2, 3, 4. And everywhere there wasn't a number, we put a 0. So this 5.8 e negative 4 is the same as 0.00058. So please remember that as you're going through homework and different assignments. If you get a probability that looks like it's bigger than 1, you can't have a probability bigger than 1, so definitely check to see if it's in scientific notation and convert it to regular notation. All right, the next thing is all the probabilities add up to be 1 in the distribution. And that's what this means. This stands for the sum of all the p of x's, the sum of all the probabilities equal 1. If we go back, if we were to add all of these up together here, they would add up to be 1. If we were to add 0.25, 0.5, 0.25, that adds up to be 1. If we were to add all of these for the decimals, for the sum of the two die, that add up to be 1 as well. So that would be how you can tell if something is a probability distribution. 1, all the probabilities need to fall between 0 and 1, and all the probabilities in the probability row or column should add up to be 1. All right, so let's use probability distribution to answer some questions. So the number of customers in a line at a supermarket express checkout counter is a random variable with the following probabilities. So here are the possibilities. You can have no one at the checkout counter, 1 person in line, 2 in line, 3 in line, 4 in line, or 5 in line. Those are the possibilities. And we give you the probability of each except for the probability of 2. So the first one says find the probability of 2. So how can we do that? Well, we can use this fact that we know they add up to be 1. So if all of these are supposed to add up to be 1, what we can do is we can add these together, see how much we have, and subtract it from 1 to figure out what the probability of 2 should be. So we're going to add 0.10 plus 0.25 plus 0.20 plus 0.10 plus 0.05. Let's see, 10, 20, 35, 45, 55, 65, 70. 0.70. So I know that what goes here needs to add to the 0.70 and give us 1. So what I can do is just say 1 minus 0.70, and you can do this in the calculator, and we're going to get 0.30. There we go, there's the 0.30. So the probability of 2 is 0.30. So we're doing the probability of each of these random variables. So they ask you for a specific number, you just pull it off the table. But let's look at number 2. It says, find the probability of no more than 1. So I'm going to go back up here. When they say no more than 1, so no more than means that number or less than or equal to. So we're doing no more than 1, so less than or equal to 1. So that would be 0 or 1. So what we can do is, what's the probability of 0 or 1? If you'll remember the keyword or, we add the probabilities. So the probability of 0 is 0.10. The probability of 1 is 0.25, so we get 0.35. So why don't you pause the video and try the other two, and then we'll unpause the video and go over the solutions. All right, so the probability that no one is in line is the probability of 0, which we can just pull off the table, so that's just 0.10. What's the probability of at least 3? So if you recall, scroll back up, at least is greater than or equal to. So we're going to be greater than or equal to 3. So that's the probability of 3, 4, or 5. So we're going to add the probability of 3, the probability of 4, plus the probability of 5. So probability of 3 is 0.20, plus the probability of 4 is 0.10, plus the probability of 5 is 0.05, and we get 0.35 this way as well. So there you have it. That's how you can use probability distribution to answer some probability questions and just be prepared for those inequality type wordings. All right. So let's go into expected value. So if an investor is considering a $10,000 investment in a startup company, she estimates that she has a probability of 0.25 of a $20,000 loss, a probability of 0.20 of a $10,000 profit, and probability of 0.15 of a $50,000 profit, and a probability of 0.40 of breaking even. Breaking even, you guys, is a profit of nothing. So you don't lose money, but you don't gain money. So would you advise her to make the investment? So to answer a question like this, we need to find what's called expected value. Expected value is also called the mean of a random variable. The notation mu with a little subscript x stands for the mean of the random variable. E parentheses x, or E of x, stands for expected value. These are the same thing, so we interchange these throughout statistics. We use both terminology, both symbols. And how do we do this? There is a formula. We can also use technology. The formula is kind of two pieces. It takes two steps. So first, you're going to multiply each random variable times its corresponding probability. And once you get those products, then you are going to add them together. So it's the sum of x times p of x. So let's look at this example. So this was the investor. If you'll recall, they had a probability of breaking even was 0.40. So that's a profit of 0. Then the probability of $20,000 loss is 0.25. So $20,000 loss, I've got negative 20,000, 0.25 next to it. The probability of $10,000 profit is 0.20. So we've got 10,000 with 0.20, and the probability of a $50,000 profit is 0.15. And so you have all of those there. They're just in a slightly different order than what they were listed, but as long as the value goes with the random variable goes with its corresponding probability, you're fine. So if we wanted to know what would should the investor expect, what you're going to do is you are going to multiply. So remember, the formula is the mean of the random variable, which is E of x, the expected value, is the sum of x times p of x. So we would start by doing x times p of x for each one. So I'm going to have another column, x times p of x. I'm going to go through them and multiply. So 0 times 0.40 is 0. 10,000 times 0.20 is 2,000. 50,000 times 0.15 is 7,500, and you can use the calculator for this. Negative 20,000 times 0.25 is negative 5,000. All right, so then after you multiply each of those, we are going to add them together. So the sum of x times p of x, we're going to add these together. Add them all together, and we get 4,500. So the expected value, so E of x, or the mean of the random variable, is 4. Oops, I wrote 4,000. I should be writing 4,500. So let me erase that and fix it. All right, so that would be the expected value. So the original question was, should she invest? So let's talk about what this meaning of the expected value really is. So since the expected value is positive, 4,500, that means she can expect to make a profit. But please note, it's impossible for her to actually make 4,500 with this. So this expected value isn't what we actually expect her to make. Instead, this means that if a bunch of investors made this investment, the majority of them would make money and their average profits would be 4,500. So basically, when you find an expected value, imagine repeating the experiment over and 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 over a large number of times. And if you took an average of all the outcomes, that would be your expected value. That's what you're finding when you do this. That's why they call it the mean of the random variable as well, because you're basically taking an average. All right, so why don't you do this one? And pause the video and try this one, find the mean of the random variable, same way that we just did on the previous screen. This one doesn't have any context, it's just numbers, but do the same thing, multiply each x times the p of x, and then add them together. All right, so I have multiplied each of the x's with the corresponding p of x's. You can check those answers, and so then when we add them together, the x's times the p of x's, we get 2.5. So the mean of the random variable, which is the same as the expected value, is 2.5. All right, so I did promise you that we would talk about technology, and the technology of choice here will be using Rguroo. So first, you need to create the data set. Okay, so you're going to create a data set. Your first variable will be your x. Your second variable will be your p of x. You probably want to identify those in Rguroo. And then once you do that, then you want to name your data set and save it. So once you do that, then you're going to find the mean of the random variable the same way you would find the mean of a normal data set, with a couple of exceptions. So you're going to go to the Analysis tab and choose Numerical Summaries, just like you do for mean. And you're going to choose your data set, and you're going to put variable 1 in the selected column. And then down here, normally we don't do anything with frequency. You're going to click this button and you're going to choose your second variable. Now, the first variable you may have labeled x, and your second variable you may have labeled p of x. All right, and if that's the case, that's what you choose there and there. So you do a selected variable, so that'd be variable 1 or x, and then you do a frequency, which is variable 2 or p of x. Then you're going to click univariate. And then once you click univariate, you're going to click mean and population standard deviation and then preview. And that's it. And you will get the mean is your expected value, but they're also going to ask us for standard deviation. And so to get the standard deviation, you would click the population standard deviation for that. And that way you get both all at once. So again, enter your data, name your variables, save your data set. Analysis tab, Numerical Summaries. Variable 1 or x goes in your selected column. Variable 2 or p of x is your frequency. Choose univariate, click mean, population standard deviation, preview. You're done. Super fast. This is just kind of showing you that earlier problem that we did up here with the expected values there. I just want to show you that I do have the same answer there. Let me see if I can show you on Rguroo. Let me see if I have the data set listed here, if I need to create a data set. I'm not sure if I have it, so let's just go ahead and create it so that we can review how to do that. So I'm going to hit data, and then I'm going to click create data set. I'm going to make, how many were there? There were 1, 2, 3, 4 possibilities, so 4 rows. and then 2 columns. So the first one was breaking even, and then $10,000 profit, and then there was a $50,000 profit, and then there was a negative $20,000 profit. And then variable 2, we had 0.40 of breaking even, and then 0.20 for a $10,000 profit, and then 0.15 of a $50,000 profit, and 0.25 of negative 20,000, of losing 20,000. And I'm going to go ahead and label my variables. So variable 1 was X, and variable 2 was P of X. You don't have to do that. You just need to remember which one was where. Oops. All right. And then I'm going to save this as investor data from discrete random variable notes. There we go. You can save it however you want to save it. Okay, so now that I have it in there, I'll put it in fairly quickly. I'm going to go to Analytics, and in the Analysis dropdown, I'm going to do Numerical Summaries. And then for Data Set, I'm going to scroll all the way down to my investor data from Discrete Random Variable Notes. And then remember, the selected, you need to click X or variable 1 and move it over into selected. And then for frequency, you're going to choose P of X or variable 2. And then click univariate, and I'm going to just click mean. That is going to be, the mean number will be my expected value, or the mean of the random variable, and then population standard deviation. So if they ask you for standard deviation, click population here, not sample. And here we go, 4,500 is your expected value. Okay, and that's all there is to it. So let me go back here, and let's look at the next example. It says the following table presents the probability distribution of the number of defects X in a randomly chosen printed circuit board. Compute the mean and the standard deviation. So we're just going to do the same thing. So you can pause the video, and then once you unpause it, come back and we will do this together. Okay, so if you've unpaused the video, I'm creating a new data set. Variable 1 is X. Variable 2 is P of X. And then this time I have 1, 2, 3, 4. Again, column or rows. And so we have 0, 1, 2, and 3 for errors. And P of X I have 0.5, 0.3, oops, it's not working, 0.5, 0.3, 0.1, and 0.1. And then just, if you're adding these together, 5, 6, 7, 8, 9, 10, this does add up to be 1. I'm going to save this as circuit board defects. Okay. All right, and then close that out and go to Analytics, choose Numerical Summaries, choose Data Set, which is circuit board, wrong one, circuit board defects, and then X or variable 1 goes into selected, P of X or variable 2 goes into frequency list, univariate, mean, population standard deviation. It's that quick. And it looks like the mean is 0.8 and the standard deviation is 0.9797959. So the standard deviation Let me just show you something real quick. Oops, I meant to click this. The standard deviation, you write the sigma with a little x next to it. It means the standard deviation of the random variable. And it was, what did we say it was? It was 0.9. I'm going to just round it to 2 decimal places, 0.98. All right. Let's do one more. In the New York State Numbers Lottery, you pay $1 and pick a number from 000 to 999. If your number comes up, you win, which is a profit of $499. If you lose $1. What is your expected value? So if you were to play this game over and 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 over again a large number of times, would you expect a profit? That's basically what this is asking. And they've been really nice here, and they've let us know that if you win 500, you have to pay $1 first. So really, you're only winning $4.95, right? Because you paid $1 first to play. So, you do get your $1 back, but that means you only win $4.99, if that makes sense. And so the probability of winning that is only 0.001, so less than a 1% chance. Or you could lose $1. So that'd be -1, and the probability of that is 0.99999. You could decide whether you wanted to use the formula here, which would actually probably be fairly quick, just because, there's only 2 rows, 2 columns. Or you could use technology. So we're going to use technology real quick. I'm going to go back to data and choose create new data set, and then X here. P of X there. And I could win $4.99, or I could lose $1. The probability of winning was 0.001, and the probability of losing is 0.999. Oops, not 0.00999. And I'm going to name this lottery. All right, so get that data in. And then once you do, it's fairly quick. So again, numerical summaries under analytics, the analysis drop down. Choose your data set, which is lottery. And then X is your selected. I'm trying to select it. And then frequency has to be your P of X, univariate. And then we're choosing mean for the expected value and population standard deviation. And then we preview it. And it looks like the mean is -0.5 with a standard deviation of 15.8. So we would expect there to be a loss. So you're not going to lose 50 cents. You can't lose 50 cents. If you play one time, you're going to lose at least $1. But if you played a large number of times, the majority of the times you would lose, and your average loss would be 50 cents if you were to take an average of all of that. And your standard deviation, the standard deviation was 15.8, I believe. All right, so you can, on your own, practice example 4. Unless you really want to do it, you can skip example 5. You can also skip examples 6 and 7, although I will have these worked out in the notes for you should you want to do those. These are not as important, but definitely practice example 4, and then if you scroll past examples 5, 6, and 7, you could try these extra examples here at the end. I will provide the answers on the filled in notes, so you can definitely check those when you're done, but these are just extra examples. And again, unless you really want to go through example 5, 6, and 7, you can omit those if you would like. But that is all I have for this section. If you have questions, please let me know.